We're talking about inequalities with absolute values and equations with absolute values. I think I'm gonna make this as one video. So check out this one video for both part one and part two, but I'm gonna post the two separately. Okay. But let's talk about absolute value. So when it talks about absolute value, is just, hey, how much of something is there? Doesn't matter if it's positive or negative, just how much. So that means when they're saying that, hey, I got five, the absolute value of x is five, that means x can be two possible answers. X could be just five, that means that, and x could be negative five. They are relatively, as far as absolute value, the same, but they are two different numbers. And the difference is, if we look at this in a number line, here's 0. 5 5 is just as far away from 0 as negative 5. So that's what absolute value is. Kind of like, hey, how far is something, whether you're traveling forward, whether I'm going from Gaiman to Liberal or from Liberal to Gaiman. Doesn't matter. I'm still traveling the same amount right here. 40 miles, 40 miles, whether I'm going from one place to the other or the other place back to the other place. So the same. So two, when we get to absolute value, there's always two possible answers, a positive and a negative. So same thing here. There's two possible answers. But before we can do that, we always got to get the absolute value by itself on one side of the equal sign. So that means we got to get rid of this positive one. So this negative one. So we're going to add one to both sides right there. In doing so, we're left with the absolute value of x minus 3 equals 5. Now, it's at this point where we make two possible answers. We're going to have a positive. That means 5 can exist here. It can be both a positive and negative 5. So we'll have two possible answers. We have x minus 3 equals 5, the normal one, the standard one that's set right there, and the x minus 3 equals a negative 5. Negative 5. So we switch the sign here, still equals. So then add 3, you get x, and right over here, x equals 8. And then still add 3, but you're adding 3 to a negative 5 this time right here, you get x equals negative 2. So x can either be 8 minus 3 equals 5, or negative 2. Negative 2 minus 3 equals negative 5. But the absolute value of either a 5 or a negative 5 is still the same. That equals 5, and that equals 5. So these are a possible value for x here. Let's try another one. A little bit more complicated, but not that much harder. So same thing here. We have to get the absolute value by itself. But to do so, we start getting rid of it. And we'll start with the furthest thing away, which is this 1. So to get rid of this 1, we'll subtract 1 from here, subtract 1 from here. So we're left with 4, absolute value of 2 plus 4n equals 24. So instead, treat this 4 kind of like if it was 4 parentheses 2 plus 4, and it kind of works the same way here, but we're not going to distribute it in. They're just going to give us more work. What we can do is just get rid of it. To do so, this is 4 times this is 4 times this, so we're going to divide by 4. Divide by 4. Common mistake is people try to distribute that in, and you can, but it's just going to give you a harder, bigger number to deal with. So let's just get rid of it like this, leaving us the absolute value of 2 plus 4n equals 6. And now that we have the absolute value by itself, we set up our two equations. We get 2 plus 4n equals 6, and 2 plus 4n equals a negative 6. So we start with the 2. Minus 2 minus 2, you get 4n equals 4, and then you divide by 4. Equals n, and right here, n equals 1. Let's see what else is good. Minus 2 minus 2, get 4n equals negative 8. Divide by 4. Negative 8 divided by 4 equals a negative 2. So these are your two possible answers for n. So that's equations with absolute value. So equation meaning equal signs. The next part of this is inequalities. Now, we remember inequalities. We did inequalities for a while. It's the sign right here. The sign that less than or greater than, or less than equal to or greater than equal to. Now, these two problems are very much different. Still similar, but very much different. So x, again, is less than 5. So it can be any value. It can go one of two ways. X can be any number less than 5, or, so just like before, this can split into two problems. The original one, x is less than 5, or x, and you change the sign, -5, but you also change the sign. Not only do you change the sign on the 5, you'll just change this sign. If it was x is less than 5, then x is greater than -5, which in this case, we're done right here. But let's look at this. X is less than 5, and x is greater than -5. So since both of these can be a true statement, they both can be true without being wrong, then you can write this as -5 is less than x, which is less than 5. So anytime you get a problem like this, more than likely it's going to be an and equality. Remember, we did these at the very beginning here. These are what we call an and, because it could be -5 and it could be greater than -5 and less than 5. And it's not mathematically impossible. Let's look at this one right here. So same thing happens here. We split up into two possible problems. This is our and. So then we also talk about our ors, and we'll see why this is an or. So we split it up. You can say, hey, x is greater than 5, which is true. And then we can do the counterpart, x, change the sign, less than, and then change the sign, -5. So the reason this is or is, just read this. Is x is greater than 5. So on our number line, we're saying, hey, here's x, or here's 5. X is everything bigger this way. But then we're saying, hey, x is less than -5. So let's say this is -5. We're going less than. Here's a problem. You can't say you're here at -5. Be less than. You can't be less than and greater than. So this is an or. So we'll write this as x is greater than 5, or x is less than -5. And this is a proper answer for this one, and this one. So the two possible answers. You get and or. And at the very beginning, you can kind of tell. If it says that x is less than a positive number, then it will be an and. But if it says that x is greater than a positive number, it'll be an or. Let's try that out. So let's see how this comes out. So here we're saying the whole value is less than 5. So more than likely this will be an and. But let's test it out. So we make our two problems. We have our original OG, 3x plus 2 is less than 5. And then 3x plus 2 is greater than, and then -5 right there. So let's start with this one. We'll subtract 2 minus 2. You get 3x is less than 3, divide by 3, x is less than 1. All right, so x is less than 1. Let's see what we get over here. Minus 2, you get 3x is greater than -7, and then you divide by 3. Divide by 3. X is greater than -7/3. All right. So x is greater than a negative value, or x is less than 1. This is an and, because these both can be true. So we write it as -7/3 is less than x, which is less than 1. Now, one thing we did not talk about, I think we'll deal with it right here. Yeah, we'll deal with it right here in this problem, is when you have a negative on our inequality, on our what we're looking for. We'll talk about it right here. So we're eventually going to divide by that. And when you divide by that, it'll switch your signs, as you'll see here in a bit. So same thing right here. Let's actually get the absolute value by itself. It's not by itself. We actually have this 9 right here. So this 9 is trying to divide this whole thing. So let's go ahead and multiply both sides by 9 before we actually make our split our inequality. So we're left with the absolute value of -9 minus 5r is greater than 18. More than likely, this is an or, as you can tell kind of from the very beginning of the sign. So we get our two problems right here. We get, and I'm going to do them in two different colors now. The first one, -9, absolute value of -9. Actually, it's gone now, the absolute value sign, because we're making the two problems. -9 minus 5r is greater than 18, and -9 minus 5r is less than negative 18. So when we do the two prime numbers, the absolute value will stay the same on both of these. It's the other side that will change. The sign will change, and the sign on this will change on the number. So let's do our first one right here. So here we will add 9, add 9. So we're left with negative 5r is greater than, right now, what does that give us, class? Yeah, I don't know, was it 17? Yeah, 18, 27, 27. Okay, now here's what happens. Anytime you divide by a negative sign that changes the sign on both sides, it will change this symbol as well. It flips it. So this will go away, leaving you a positive r now, but this will now change to less than, like that. And we take 27 divided by that, you can't actually divide, so we leave it as negative 27 over 5. Okay, anytime you divide by a negative across the inequality like that, it changes your inequality as well. So that changes that well. So that's one answer. Let's look at the other one. It'll happen over here as well. So we add 9, there. 18 minus 9 is a negative 9. So we got negative 5r is less than negative 9. And then we divide by that negative 5. Divide by negative 5. When that happens, again, this now becomes positive, but then it changes the symbol the other way. And then negative divided by negative is a positive 9 over 5. So r is less than a negative number, or r is greater than a positive number. Again, this is an or because you can't have both of them exist. So this is your final answer. But remember, anytime you divide by a negative symbol, negative sign, across it, the equal sign, or across the inequality, it will change that. It will change that. Again, if you have an equal sign, you flip it, you still looks the same. So it's kind of the same idea here, but we just don't ever see the flip. Here you do, because these represent two different things. These are the same thing regardless. These are not. These are not. Here you're saying the value of r is less than this negative number, or the value of r is bigger than this positive number. So that's the biggest thing to remember. So when you divide by a negative, it switches your inequality. Hopefully that helps. Catch you guys on a different day. Bye.